WELD 2396 class. We're going to be covering module 7, which is how to stick weld cast iron. So the first thing I wanted to tell you guys is this. You have to understand before you're going to weld cast iron, what kind of cast iron are you dealing with, okay? Now I went on the internet, you guys, and I did a bunch of research. Fortunately for you guys, I will tell you guys one thing. The majority of products that are built or the cast fittings that you guys are going to weld out in the industry is made out of gray cast iron, okay? But what we should always say is you need to be able to identify what kind of cast iron you're working with, because not all cast iron you can weld. And you can see here that I got some different things. So gray is probably the most common. You guys can weld it. They say it's difficult, but it's really not difficult to weld it. It's difficult to weld it and not have it re-crack, but that's what I'm going to teach you how to do, okay? White, you guys, is probably the hardest cast iron of all. They use these in rollers and crushers. It offers the most wear, abrasion resistant kind of cast iron that there is. Ductile cast iron, you guys, you can weld it, but ductile cast iron is real rare, okay? And of course, malleable, they say don't weld it. I've never seen malleable, but they say the reason why you shouldn't weld it is because you can actually mess up the properties in the steel because it's malleable cast iron. So we're going to be treating cast iron today as if it were gray cast iron, you guys, or even white cast iron. With the techniques I'm going to give you, you can probably get away with it, okay? You're probably not going to deal with any white cast iron unless you were like near the mining industry or that. That's really uncommon stuff, you guys, okay? So the thing that I want to talk about is what rod we're running, okay? Now, if you guys look here, on here, you guys can see a lot of people say, well, Ron, what are we doing? Do they sell cast iron rod? They don't sell cast iron rod, you guys. We use nickel rod. Nickel is what stick welders will use to weld cast iron. Now, I was going to tell you guys, it doesn't matter what manufacturer you guys go through, okay? Lincoln, ESAB, Miller, they all make these nickel rods, okay? And they all claim that their rod is the best. What do I always tell you guys? Pick a rod that's appropriate and the way you like that it runs, and just leave it at that. But what I want to tell you guys is there's really two types of nickel rod out there. It doesn't matter what manufacturer. You guys can see this is nickel rod. It's 1/8 inch, but it's 55. Okay, now I'm going to tell you about this. This 55 means it has 55% nickel content. It's a cheaper way to weld it, okay? It's more ergonomical, meaning it's more cost appropriate for somebody if you're watching your budget. What I would tell you guys is where you will find the premium of nickel rod out there is when it says 99%. That means it's 99% nickel, but you're gonna pay for what you get. It's gonna cost you a lot of money, but like I said, that is the premium rod, is the 99, okay? They sell this rod in all different diameters. Once again, pick a diameter that's appropriate for your material thickness. If you don't have the right size rod, what can you do on thicker metals? That's right, you can multi-bead it if you need to, okay? So, when we talk about this, you guys, one of the biggest things that I always see a lot in our industry is 9 times out of 10 when you're welding cast iron, it's probably due to a repair. Somebody's that's broke something, or you got to fix it, it's an antique piece of cast, and there's a lot of people struggle with how to weld cast iron, because right when they're done welding it, by the time you lift up your hood, you will actually hear the part pinging and making these little kind of crack popping sounds, and when you look real close, you'll see that it'll crack as you're watching it right after you weld it. So I'm going to give you some tricks, okay, on how to weld cast iron. If you're doing a repair on something, like to give you guys an idea, I did an engine block a few years ago. Well, it's been 10 years now, but they had already tried welding it, brazing it. They did all these different applications, and it kept re-cracking. It's because they really didn't know how to deal with cast, okay? So let me give you an example. You have a piece of cast metal right here, okay? We're gonna say this is how this engine block was. And what happens is it had a crack in it, we'll say right there, all right? Now, the first thing you gotta understand is, how do you deal with cracks on cast iron? It's pretty simple. First thing is, you have to prep your material, okay? We know cast iron has a lot of carbon in it. That carbon is extremely hard, and that's what's making it crack, because even when it cools at room temperature, it's too fast. It becomes too brittle. So the first thing you need to do is you need to clean your material. So what I always do is I'll get a hand grinder with a wire wheel, and I'll go through there and I buff all around. I don't want anything to pull it in there. You know, any mill scale or anything. I want the metal as pure as I can get it, even though cast material is not the purest of it. Once I've cleaned the crack and the perimeter area, there's a couple things you got to understand is you can't just weld over the crack and think it's going to stop. Anybody will tell you you can weld on that crack and it'll just keep cracking. So what we have to do is we have to be able to stop the crack, okay? So the first thing I do is I'll look at the diameter of the crack. Like, let's say it's an 1/8 inch. What I personally do is I'll select a drill bit that is like maybe a 1/16 bigger than the crack, and what I do is I drill out the crack on each side. So you guys can see that I drilled that crack out. The center of the drill bit is right at the edge of the crack, and what I do is I drill it out until I go as deep as the crack is. That, when you drill a crack out, it will actually get it to where it stops it from re-cracking, okay? Then, once I clean the perimeter in the weld, I've drilled out, I use a basic hand drill for it. Then what I'll do is I'll get a hand grinder and I'll groove it. So I'll stand the hand grinder up, straight up, and I'll just groove that crack out. So then, what kind of groove am I putting in it? Well, basically I put a U-groove in it. Anytime you use a hand grinder to you know, clean a crack out, it's going to put a U-groove in it. And just like the drilled holes, I'll U-groove it as deep as that crack is. Now, right now, from what they say, all this stuff is tough to weld, almost, you know, weldable, no weldable. Well, it's because what we learned, it's not how hard it is. First thing you need to understand is, when you look on the internet, like what I did to do one research, some of the websites were saying you do not need to preheat cast iron at all. I kind of disagree with that. It's just a personal thing, you guys. What I was always taught by some of the best stick welders in the industry is you always preheat this up. So what I was taught is this. You need to preheat it, you guys. So we've done all the initial work, the prep work is what we call it. It's the work that's not so fun, okay? I need to preheat that. Now, there's different ranges you can preheat, okay? I was always taught to go to 500 degrees, always, okay? In doing a lot of research, you guys, some of the metallurgist folks in our metallurgy industry recommended you could go from 500 all the way up to 1200 degrees. Now, I know what you guys are thinking. So how do you hit these marks, right? So welders, it's unfortunate that in most welding companies, you don't have ovens and things like that. We're not a full throttle heat treatment plant, right? So what a welder does is we have that trusty heat source. What is a heat source that welders use all the time? The cutting torch, right? So what I do is I'll get either, you know, my oxyacetylene torch. If it's a thinner part, I'll just use a regular cutting tip. I just won't hit the cutting lever to preheat it. If it's a thicker part, I'll get my oxyacetylene unit and go to a rosebud because it's going to generate more heat, right? Now, I've already done all the prep work, the elbow grease. I've drilled it out to stop the cracking. I've U-grooved the crack as deep as the crack is. Now, when you're going to heat it up, all you do is get a regular neutral flame, just like you're going to set to weld or cut. How do you know when you're going to heat this temperature? So I already told you, I personally have been taught to preheat cast iron to 500 degrees. Well, you got a student that says, okay, I'm going to start heating it, and I'm going back and forth on the crack to preheat it. Now, how do you know when you're going to hit the 500 degrees? It's very simple. Before I started this procedure, you go over to Masson Trigas or Airgas or Argyle Welding, and you buy what's called a temp stick. Temp sticks, you guys, look like a little Crayola, and they have a degree on it. So I bought the 500 degree one. Now what's gonna happen is you can either use a temp stick. Trent's probably laughing right now because temp sticks are old school. Nowadays, a lot of welders use temp guns, you guys, for like what they do in automotive. So you could buy a temp gun from Harbor Freight or wherever you guys want and hit the part that way too. I like temp sticks because they're cheap. So the thing is I buy the 500 degree temp stick, and what I'm gonna do is I'm gonna start preheating my metal all around it. And I'll take that temp stick and try to mark on it. And what's gonna happen is if it's not to 500 degrees, it's not gonna do anything. I'm gonna mark on it and there's nothing gonna be there. So I keep heating and heating, and I'm gonna keep checking it with that temp stick. Well, once I heated it up hot enough, and I finally mark it, and a little bit of it goes on there, it's gonna be like a glazed Crayola mark on a piece of paper. That's when you know you've hit the temperature. Now, I turn the oxy-acetylene unit off, and I'll proceed to use a nickel rod, and what I'll do is that U-groove looks like here. So what I'll do is I'll lay a weld here, and then a weld here, weld here. Well, what do you notice I'm doing? It's a lot like welding a regular groove. I'm basically filling it up, hitting toe to crown. And we learned in previous videos to hit toe to crown, you have to split the rod on the toe of the previous weld. So that's how you do it. You don't want to leave crevices. If I was a beginner and I messed up, and like let's say I laid a weld here, well, you can see you have a crevice right there. It didn't tie into your U-groove real well. So that will eventually crack out if you don't fix it. So if you ever do mess up and you don't get good tie-in, all you got to do is get a hand grinder and re-U-groove just that spot right there and run another bead. So all I'm doing is filling that crack up toe to crown. If I have a crevice, I U-groove the crevice and lay another bead. Once you get it above the surface, you guys, so this thing's all welded out. So I'm going to tell you guys, if you've ever welded cast iron with nickel rod, you treat it a lot like 7018. All you do is set your work angle, set your 10 to 15 degree travel angle, and you don't do any manipulation besides drag it. Sure, you can add a side to side, and I have seen some people weaving it. Me, I like to keep stuff simple. Toe to crown stringer beads, they're tried and true and they work for beginners. So it's just a basic drag technique, okay? Now, once you've welded it all up, this is where cast iron gets tricky, is as it cools. What happens is cast iron has so much carbon in it. You gotta remember that even an air quench is too fast. The faster it cools, the harder that material is gonna get. And what I've seen is, I have seen welders that weld cast iron. That was easy. You lay down a bead, carry a puddle, don't long arc, carry a puddle, it's 2 to 3 times the size of the rod, and they're like, cast iron's easy, as they flip up their hood. And all of a sudden while we're visiting, you'll hear these cracks and pops, and you start looking close, and a lot of times, it'll either crack down the toe, or it'll crack down the crown of all your welds. And you'll actually see, if you look real close, a little hairline crack. That's because even an air quench in room temperature is cooling it too fast for the amount of carbon in it. So this is where the tricks of the trade are, okay? I have actually welded cast iron parts that were very small and actually put them in the oven in my kitchen, and it works that way. So you turn the oven to 500 degrees, you weld it, you put it in your oven that's set to 500, right? And you slowly step it down, you know, 450, and then come back an hour later, 400, come back an hour later, 300. That's one way you can do it. Trent showed me a trick a few years ago. He was teaching metallurgy, and he had a big old bucket of vermiculite. That works too. You could weld that stuff, stick it in there, and let it cool real slow. Well, you guys know I was a fill welder, so you got to get pretty creative. You don't have ovens on a welding truck. I wasn't going to carry a big old 5-gallon bucket of vermiculite. And what if the part I was welding wouldn't fit in a bucket anyway? So what we used to do is use sand. And what I would do is get the old burlap bags, put a bunch of sand in it, and then seal it up. Well, when I was done welding this, I take a burlap thing of sand and I flop it on there, and basically it covers the whole thing. Well, anybody knows that when you cover something with sand, you're insulating it, and it's cooling extremely slow, and it may take hours to cool to the touch. So that's what you want. You're trying to cool it real slow. There were times out in industry I didn't have sand, I didn't have a burlap bag, I didn't have an oven. So how do you do it? Once you weld it, you can take a torch and just wave it across there a few times. You know, every now and then, just take it and wave it, and just you're trying to bring it down to room temperature a lot slower. The trick too, you guys, not only bringing down the temperature slow, is after you're done welding it, you need to do what's called peening. And for a long time I thought, what kind of, this is some kind of hard process. No, you take a little 2-pound sledge, or you take a ball peen hammer, and after I'm done welding it, what I want to do is basically tap up and down that weld. And what this does is it gets it to relax. So I'm just tapping up and down that weld. You don't have to hit it so hard you're denting it, nothing like that. And basically what you do is you peen it for a minute or two, and then put your sand on it, or put it in an oven that you make out, and cool it down to room temperature of that. So remember, go over everything, know what cast iron you're welding, know which nickel rod you want. If you're on a budget, go with the 55%. If you want the premium rod, go with the 99%. You have all the procedures. What stops cracks is if you drill holes, right? Cleaning your metal, doing the elbow grease that you need. Treat this rod just like 7018. You can weld it in any position and enjoy. So hopefully you guys get something out of this cast iron, maybe some new tricks that you have in your, you know, that you can implement to make you a more well-rounded welder. We'll see you in the next video.